All right, we've spent the last couple days talking about measurements and how important measurement is. And as a scientist, when you measure things, they're super important things to do. You have to be precise and accurate. And how are you precise and accurate? Well, there's a couple things. Precision is how close your measurements are to one another. So let's say, for example, I'm measuring how tall I am. I am 6 feet 4 inches tall. But for some odd reason, when I measured me, and I did 3 measurements, I measured myself as 8'1", 8'2", and 8'1", 3 times. Now, is that very close to how tall I am? No. But are all 3 measurements very close to one another? Yes. So that is precision, how close my measurements are to one another. If we use this as a dart example, and I am aiming for the bullseye, and I throw my darts here, here, and here. That's not anywhere close to my intended target, but they are very close to one another, so that is precise. If I am accurate, that means I am around my target goal. So again, I'm 6 foot 4 inches tall. Let's say I'm going to measure how tall I am again, and I got 6 feet, 6'6", and 6'2". Now it's not the perfect, but I'm right around how tall I am. So if I was aiming with darts for accuracy, I would throw a dart. If I was aiming again for the bullseye, I threw a dart here, here, and here. I didn't hit the bullseye, but I was right around it. And as chemists, or as scientists, we want to be precise and accurate so we can hit the bullseye, boom, boom, boom. So when I do that measurement, I'm 6 foot 4, 6 foot 4, 6 foot 4. How do we do that? Well, we do that through the use of significant figures, making sure we have very good measurements. And what is a significant figure? Well, when you measure something, you want to be as accurate and precise as possible and measure it to the farthest decimal place that you can. So I could say it takes me 6 minutes to go somewhere. 6 minutes is only one number. I also could say it takes me 6.35 minutes to get somewhere. That is 3 numbers, so that has 3 significant figures. Which number do you think is better to use in a scientific experiment? 6 or 6.35? The 6.35, because it has you measured out further. So what we're going to do is we're going to go through the rules of significant figures, and then we are going to end up practicing them a ton in class. So let's look at the rules of significant figures. Rule number 1. All non-zero numbers are always significant. That's easy. When we do sig figs, we only focus on the zeros. Why? Because every other number counts. So now we got to figure out, sometimes a 0 counts and sometimes it doesn't. So when does the 0 count and when doesn't the 0 count? It all depends on if you actually measured it. So rule number 2, all zeros between non-zero numbers are significant. Holy cow, what the heck does that mean? Let's do an example. Pretty much it means if we have a 0 sandwich, it counts. So if I have a number 909, it's between 2 numbers. That 0 counts, so 909 would have 3 significant figures. If we did another example, 1111, that 0 is between 2 real numbers, so it counts. This would have 4 significant figures. Now let's do another example. 600. Is there a 0 sandwich there? No. So neither of these zeros count. So in this example, 600 only has 1 significant figure. But if I would make it a sandwich and go 6005, again it's sandwiched and it counts, and this would have 4 significant figures. All right. So that is rule number 2. If you create a sandwich, if a 0 is between two real numbers, it counts. How about the third rule? All zeros which are simultaneously to the right of the decimal point and at the end of the number are always significant. What does that mean? Well, that means this. 16.00. In that case, the zeros count. I have 4 sig figs here. If I did 14.0, that 0 counts. How about if we combine these two rules and we go 100.06? Well, taking our rule from number 2, do we have a 0 sandwich here? These zeros are all in between real numbers, so they all count, and we have 5. We could go 75.01. That 0 is in between two real numbers, so that counts, and we have 4. If you are starting to get confused, that is okay. It is going to take some time for this to sink in. We are going to spend time practicing this in class. But the reason this is important is if you make bad measurements, you're not going to be very accurate in class. All right, next one. All zeros are which is to the left of a written decimal point and are in a number greater than 10 are always significant. So all zeros which are to the left of a written decimal point and are in a number greater than 10 are always significant. We've kind of covered that rule already, so I won't do an example with that rule. Last rule here, number 5. A helpful way to check rules 3 and 4 is to write a number in scientific notation. If you can get rid of the zeros, they are not significant. Right. So that is kind of the sig fig rules. So we are not even going to touch sig fig math at all yet. We are just going to focus on sig figs. Now on the quiz tonight, I'm going to give you a couple examples, and all I want you to do is tell me how many significant numbers there are. So take your time, look at your rules. We will practice this in class. So if you have questions, save them for class, and we will get them answered for you tomorrow.